Good morning, children. Children, I welcome you all to today's session of physics. And we are on to chapter 5, which is heat. Right, children? Heat. Right? We all know what is the utility of heat because if there is no heat, then most of the food which we eat cannot be cooked. Right? Also, sun gives us heat, and there are other things also. So, we'll be discussing all this in detail in this chapter. Now, children, heat is a form of energy. This is something very important that you should know that heat. What is heat? Heat is a form of energy which makes things hotter, right, or cooler, right. It cannot be seen by us. We can feel the heat by temperature effect it produces, right. So when heat is given in to a substance, its temperature increases and it becomes hotter. For example, when a utensil is kept in gas burner, it gets heat. Its temperature increases and it becomes hot. On the other hand, when heat is removed from a substance, then its temperature decreases and it decreases and it becomes cold. Right? The SI unit of heat is joule. Yes, children, this you should know by heart, right. And heat is sometimes expressed in calories also, or in kilocalories if the heat is too much, right. Then hot and cold in our daily life we come across a number of objects. Some of them are hot while some of them are cold, right. And usually we decide if anything is hot or cold by touching it, um, right. Sometimes our sense of touch is not reliable to tell us whether it is hot or cold, right. Then what we do is we need certain equipments, right. From the above we can conclude that we cannot depend on our sense of touch for estimating the hotness or coolness of an object. We need some reliable measures for estimating the hotness and coolness of an object. A reliable measure can be measurement of the hotness of an object and its temperature. We will now discuss about temperature, right. A temperature of an object is the degree of hotness or coldness in an object. The temperature of an object tells us how hot or cold it is. A high temperature of an object tells it is very hot, low temperature tells it is quite cold. Right? For example, for boiling water it is 100 degrees centigrade, that means it is quite high. Right? So for melting ice it is 0 degrees Celsius, which is quite low, hence it is very cold. Now temperature is measured by a device called thermometer. See children, it is just a minute. Thermometer, right? Okay. So a thermometer has a scale marked on it which is used to read the temperature. Now the units of temperature are Celsius scale. First, in this or centigrade, we call it from both the name. It is Celsius as well as centigrade, right? And each division here is of 1 degree. And in Celsius scale, the lower fixed point is 0 degree and the higher fixed point is 100 degree. The other is Fahrenheit scale, and it starts at 32 degree Fahrenheit, see, and ends at 212 degrees Fahrenheit, right. Also clinical thermometers has the measurement from 99.95 degree Fahrenheit to 110 degree Fahrenheit, right. Okay. Now children, for you to remember here is something very interesting, that the normal human body temperature is 98.4 degree centigrade. The next comes is Kelvin state, right, named after Thomas Kelvin, a British physicist who devised it, right. And these temperatures are called Kelvin, and they are denoted by this formula. This formula you need to learn, children. See these three formulas. Okay. Now we move to the difference between heat and temperature. Heat is a form of energy, whereas temperature is the degree of hotness or coldness in a body. It does not determine the direction of the flow of heat. Temperature, it determines the direction, right? That heat always moves from cold to hot, or from a body of higher temperature to a body of lower temperature. Heat is measured in joule or calories, the same unit as energy. Temperature is measured in Celsius, Kelvin, or Fahrenheit. Now we have different types of thermometers depending upon their usage. A laboratory thermometer is used for measuring the temperature in a science laboratory, right? A laboratory thermometer is made up of a long glass tube. See children, this is the diagram is here, right? Long glass tube having a thin bore. There is a glass bulb B containing mercury, which is joined at the lower end of the glass tube. The top end of the glass tube is sealed. After removing that, the whole length of the thermometer glass tube is graduated in degrees Celsius. The graduation mark on the tube of a commonly used laboratory thermometer are from minus 10 degree to 110. See, this is something which you need to learn. Minus 10 to 110 degree centigrade. Laboratory thermometer can measure temperatures from minus 10 degree to 110 degree centigrade, and this is called the range of the thermometer, right children? What it is called? It's called the range of the thermometer, right? We can see a thin silvery thread of mercury in the narrow glass tube of the thermometer. The upper end of the mercury thread tells us the temperature, right? Okay. Now there are some precautions which are to be taken by using a laboratory thermometer. The laboratory thermometer should be held vertically or upright while measuring the temperature, right? It should not be tilted, otherwise it will give a false reading. Second, thermometer should be surrounded from all sides by the substance whose temperature is to be measured. The thermometer bulb should not touch the sides or bottom of the container in which substance is taken. Read the thermometer while its bulb is still in touch with the substance, right? Now read the thermometer by keeping the level of mercury along the line of sight, and do not hold the thermometer by the bulb. Handle the thermometer with care. Next is clinical thermometer, which we have seen in our houses also. This is also called doctor's thermometer. The normal temperature of a human being is 37 degrees centigrade, right? And generally the doctors are having it, right? And here there is mercury in the bulb, right, whose upper end tells us the temperature of the body. The clinical thermometer is marked from 35 degrees centigrade to 42 degrees centigrade, right? There is a kink there which is there to prevent the backflow of mercury, right? The kink is there to prevent the black flow of the mercury. Now precautions: the clinical thermometer should be washed before and after, right? It should be before using the clinical thermometer. We should ensure that mercury level of the tube is 35 degree. You would have seen the doctor jerking the thermometer. Read the clinical thermometer by keeping the level of mercury along the line of sight. It should never be held with the bulb, and handle the clinical thermometer with lot of care. A clinical thermometer has usually two temperature scales marks. One is centigrade, the other is Fahrenheit. Right? Both the scales are there. For Fahrenheit, the range will be 94 to 108 degrees Fahrenheit. Next we have is the digital thermometer, right? As it is believed that mercury is a poisonous substance, and entry of mercury as an impurity can cause damage. So in this digital thermometer, everything is electronic. And lastly, we see the maximum and minimum thermometer. It is used to determine in meteorological office, in weather department, this kind of thermometer is there, and it tells us the highest and lowest temperature reached in the surrounding during the whole day, right? So then the effects of heat, let us come. The first is change in temperature, right? If we increase the heat supply, then it gives out heat energy and its temperature decrease, right? Okay, when heat is supplied to a body, solid, liquid, or gas, its temperature rises. When this hot body gives out heat to its temperature decrease. For example, when you heat cold milk in a pan, its temperature increases and it becomes hot. And when you put this hot milk on the table for some times, then it becomes cold again, right? Change in size, right? When an object is heated, it increases in size. This is also called expansion. And when that same hot object is cooled, then its size also reduces. Now, expansion in solid. Let us take two blocks of wood and place an iron or a tin rod in them. Fix the rod firmly on one side. Insert the pencil under the other end of the rod. Make it a pointer and stick it to a edge of the pencil. Place a sprit lamp under the rod and heat the rod. This iron rod, let us heat. Right, you will observe that the pointer moves to the outward direction. It is because the rod has expanded and when heated and pushes the pencil outward. Right. So, what are the effects of expansion on solid? Firstly, gaps between rail joints. These are some practical applications. Gaps are left between rail joints to allow for expansion. The long distance railway line is obtained by joining together a large number of steel pieces called rails. Small gaps are left between rail pieces to provide spaces. See children, this we have seen more often than not in the railway lines, railway tracks which are there. We had seen it. The gaps are there and they are specifically so that when during heat this railway line expands, then these gaps are filled. See, it's like this. It's shown in this diagram also, right? Now, I think we should stop here, right? So I hope you enjoyed it as much as I did in making it. And until we meet again, it's a goodbye.